Hello everyone. So today we are going to start OpAmps. OpAmp full form of OpAmp is operational amplifier. So when you are studying MOSFET in the feedback topology topic, in feedback amplifier topic, we have studied different kind of feedback topology as well. So there we studied basics of OpAmp, right? And now we are going to continue studying about OpAmp only. So if you are studying OpAmp for the first time, I would highly recommend to go through feedback topologies as well, feedback topology and feedback amplifier. And then if you move towards OpAmp, it would be very easy for you. Okay, so let's start. So this is the IC of OpAmp. This is how a OpAmp looks like, and this is the internal structure. So OpAmp have an input resistance, and difference voltage will be coming across the input resistance, and that will be amplified with the factor of A, and there will be a R naught resistance. I will be moving a bit fast because we have already studied it in the previous topic, right? So difference voltage is coming, that is being amplified with the factor of A, and there is a R naught resistance at the output. So what is the amplified voltage? What is your V naught? So V naught is A into Vd. Difference voltage that will be amplified with the factor of A. So that is your V naught. Else or else what you can write? What is your Vd? Vd is V positive minus V negative. Voltage of positive terminal minus voltage of negative terminal. It's not V negative minus V positive. It is V positive minus V negative. Difference of positive terminal minus difference of negative terminal. This is your V naught. And there is a very simple thing, that is, if V positive increases, then your V out will increase, and if your V negative increases, then your V out will decrease. And for an OpAmp, this is the internal structure of an OpAmp, internal structure. So for an OpAmp, Rin is high, the gain is also high, and R naught is low. And for ideal, this will be infinity, this will be infinity, and this will be 0. Well and good, very easy thing. And this is how you can also write V naught is equals to A V positive minus V negative. One more note, that is output of an OpAmp cannot keep on increasing or decreasing, right? The output of an OpAmp cannot keep on increasing or decreasing. It will saturate at some point. We will see an example, it will be more clear to you. So this is a very important point, that output of an OpAmp cannot keep on increasing. This we have already seen previously, that's why I am keeping it a bit faster. So output of an OpAmp cannot keep on increasing or decreasing. It will saturate at some point. Let's take an example now. So it will saturate, this is the saturation voltage, plus V side and minus V side. Whatever the saturation voltage is given, at that point it will saturate. So let's take an example, it will help you understand better. So saturation voltage is given, that is plus minus 5 volt. Difference voltage, different voltages are given, difference voltages are given, and the gain of OpAmp is 10 to the power 3. The gain of OpAmp is 10 to the power 3. So what will be the output voltage? So what is the output voltage? Output voltage is A into Vd, right? Vd is V positive minus V negative, it is given. So output of OpAmp is A into Vd. So 10 to the power 3 into 2 milli. Vd is 2 millivolt. So output of OpAmp will be 2 volt. That's it. This is the correct answer. Why is this correct? Because it is lesser than the saturation voltage. It is lesser than the saturation voltage. What about this? What about this? Let's solve this one first. V naught is equals to A into Vd. 10 to the power 3 into Vd is minus 3 milli. So it would also be minus 3 volt. So V naught is also minus 3 volt. That is also correct. There is no issue with this. What about this? V naught would be equals to A into Vd. A is 10 to the power 3. Vd is 5 millivolt. So output will be 5 volt. That is also correct, because that is also within the range of saturation voltage. 5 volt plus minus 5 volt. So this is also correct. What about this? V naught will be equals to A into Vd, 10 to the power 3 into minus 5 milli. So output will be minus 5 volt. This is your output. So this is also in the range. This is also correct, right? What about this? Vd equals to 7 millivolts. So what will be your output? A into VD, A is 10 to the power 3, 7 milli. So output is coming to be 7 volt, but it cannot rise above 5 volt. The output cannot rise above 5 volt. So it will be saturated at 5 volt only. Right? So this is wrong. The answer would be 5 volt, because your output cannot rise above 5 volt. It will be saturated. What about this? V naught is A into VD. A is 10 to the power 3. VD is minus 8 milli. So your V naught should be minus 8 volt. But it cannot go below minus 5. The range is minus 5. So your output can be between minus 5 to plus 5. That's it. So your output will be saturated to minus 5 volt. That's it. So basically what you can see here is that I should write here. What you can see here is that your output will be always greater than minus V set and less than minus V set, plus V set, less than plus V set. That's it. This is the range. Or what else you can write? What is your output? Output is A into VD. Oh, forget it. No need to write all those things. Just a simple point that output will be between these 2 points only. Minus V set to plus V set. So how will you make the characteristics? If I make the transfer characteristics. Transfer characteristics. Tell me how it will look like. I am drawing V naught versus VD. This is your V naught versus VD. What is VD? VD is V positive minus V negative. Positive potential minus negative potential. So what is V naught? V naught is equals to A into VD. So ideally it should be something like this. It should always be looking like this, right? It should always be having a slope of A. But now, after some point, it saturates. So after a particular point, it saturates. After this particular point, it saturates. There will be some point. After that, it will saturate. Output cannot keep on increasing. At some point, it saturates. So it will saturate at plus V set, and this will saturate at minus V set. And what is this slope? What does this slope represent? The slope represents the gain, that is equals to E. Well and good. Now what will be this value? What will be this value? This value will be plus V set by A, and this value will be minus V set by A, right? Plus V set by A. How it is plus V set by A? Because what is your output? Output is plus V set. Your gain is A. What is your VD? That you need to find. So VD will be plus V set by A. Similarly, it will be minus V set by A. So not an important point. The important point is the slope is like this and then it saturates. That's it. Although the slope, it feels like it is very low. I have made it look like very low, right? Here, what do you think? What is the value of theta? If you see the graph, it feels like the value of theta is 45, tan 45. It feels like the gain is 1. You feel like that the gain is equals to 1. But no, gain is very high. The slope is very high actually. The slope is something like this. Okay, it is pretty high. It looks like this. But just to show you in the diagram, for a better clarity, I have made it more clear. But it will be very near to y-axis because the slope is very high. Because why so? Because the gain is also very high. If the gain is very high, so the slope has to be very high. So slope would be looking something like this. But to make it clear to you, I have made it a bit wider so that you could understand better. Well and good. Let's move towards ideal OpAmp. So what is an ideal op-amp? So for an ideal op-amp, your gain A will be infinity, your Rin will be infinity, and your R0 will be 0. So basically, let's just make an op-amp. This is V positive, this is V negative, and this is your output V0. This is your gain A, and this is Vd. Right? So there is this infinite resistance. Input resistance is infinity. Now it is amplified with the gain A. So even this battery will be of infinity magnitude, right? But let's just show it like this only, and the R0 will be 0. This is your V0, where A is infinity. So let's just forget about that. But this is how your op-amp would look like, the internal structure of op-amp, because Rin is infinity and R0 is 0, right? So let's see how would the characteristics look like now. Let's see how the characteristics would look like. Okay, so the gain, ideal op-amp is there, the gain is infinity. For an ideal op-amp, the gain is infinity. What will be your output if these differential voltages are given? So what will be the output? Output will be A into Vd. What is A? A is equals to infinity. Vd is 3 millivolt. What will be output? Infinity into some value. Infinity only. But the output cannot go towards infinity. It will have to saturate at some point. That is equals to its saturation voltage. So it should have been given in the question that your plus minus V set is plus minus 5 volt. So your saturation voltage is 5 volt. So output cannot keep on increasing. It will saturate at plus 5 volt. Well and good. So you are getting output equals to infinity, but you know one thing in op-amp, the maximum value it can attain is plus 5 or plus V set, and the minimum value it can attain is minus V set. That's it. What about this? V0 will be A into Vd. What is A? Infinity. What is Vd? Minus 2 milli. So what should have been the answer? Minus infinity. Infinity into some minus value. It would be minus infinity. But that is not correct, because output cannot go below minus V set. And what is the value of minus V set? That is minus 5 volt. Right? What about this? V0 is equals to AVD. So A is infinity, Vd is 7 millivolt. That would be infinity. So V0 will be plus 5 volt only. Right? Because this cannot be correct. So what did you understand? Even if there is a slight Vd, if Vd is greater than 0, your output is plus V set. If Vd is less than 0, your output is minus V set. Are you getting this point or not? If your Vd is greater than 0, Vd is greater than 0, that means infinity into something greater than 0, that will be infinity only. So output will be saturated at plus 5, because output cannot keep on increasing. The maximum voltage it can attain is plus 5 only, and the minimum it can attain is minus 5. That's it. What about this? What will be the output here? A into Vd, that means infinity into minus 6, that would be minus infinity only, but this is not correct. So your V0 will saturate at minus 5 volt, right? So what did you understand here? So how will the ideal characteristics look like? What is your Vd? Vd is V positive minus V negative. So if Vd is greater than 0, or you can say V positive is greater than V negative, then your output will be just saturated. It will be at plus V set. And if Vd is less than 0, if Vd is less than 0, that means if V positive is lesser than V negative, that means V negative is larger. If V negative is larger, then output will be saturated, but at minus V set, right? Because the gain is already infinity. So if the gain is already infinity, the gain is already infinity, right? So for just greater than 0, plus V set, and for just less than 0, minus V set. Minus V set and plus V set. Well and good. This graph is same as this graph only. Just the slope is infinity. This time the slope is, the slope is 90 degree. This time the slope is 90 degree. Here there was some slope. Let's just remove it. It feels like 45 degree, but it's not that. Here the slope is not 1090. 1090 is infinity only. So slope is infinity. So there is a straight line which is passing through y-axis, right? Plus v set and minus v set. This is how the characteristic would look like. Now we will use OpAmp as an comparator. So what is an comparator? So there is an input voltage given, and then there is the other node is grounded, right? So what will be your output? So what does a comparator do? Comparator compares two voltage. Comparator compares two voltage. So what do you think? What will be your output? OpAmp is ideal. OpAmp is ideal. You need to find V0 for the given input. What do you think? What should happen? And if we solve this particular problem, so if Vin is greater than 0, what will be your output? It will be plus V set, right? If Vin is greater than 0, your output will be plus V set, because gain A is infinity. It is given, the OpAmp is ideal, so the gain A is infinity. So if Vin is greater than 0, that means V positive is greater than V negative. If V positive is greater, that means output will be saturated at plus V set. And if Vin is less than 0, why 0? Because this node is 0. So for better understanding, I should write, if V positive is greater than V negative, then what happens? Your output is plus V set. So what do you get from here? V positive is V in, V negative is 0, then your output will be plus V set, right? So if V in is greater than 0, your output is plus V set, and if V in is less than 0, your output will be minus V set. So if V positive is less than V negative, then your output will be minus V set. So what is V positive? V in. V in is less than 0, then your output will be minus V set. Well and good. No doubt about that. So how will the characteristics look like? Oh, here it is. So till this point, V in is greater than 0. Here, till this point, V in is greater than 0, right? So let's just call this as T by 2, this as T, this as 3T by 2, this as 2T. So if V in is greater than 0, your output is plus V set. Then it goes to minus V set. Then it goes to plus V set again. Then it goes to minus V set again. Then from minus V set to again plus V set. Again plus V set, and so on. So from a sinusoid you are getting a square wave. So if in the interview sometimes someone asks you, how will you get a sinusoid from a square wave? So what you will do? You will say that, sir, we will use OpAmp as a comparator. Then we can get a square wave from a sinusoid. So this is how the characteristics would look like. Very easy question. Let's see the similar kind of questions later on. So now we will see this question. Now the OpAmp gain is 10 to the power 3. The gain of OpAmp is finite. So OpAmp is not ideal this time. So what will be your output now? So what will be your output? V0 is A into Vd. Forget about saturation voltage, all those things. Forget about saturation voltage and all those things. So A into Vd. What is A? A is 10 to the power 3. What is Vd? V positive minus V negative. What is V positive? V in minus 0. So this is your V0. So simply your V0 is 10 to the power 3 into V in. So whatever this input waveform you see, that will be multiplied with the factor of 10 to the power 3. So this waveform will be completely multiplied with the 10 to the power 3. So what you will get if you multiply this waveform with 10 to the power 3? So what will be the maximum amplitude? 10 millivolt will be multiplied with 10 to the power 3. So what will be the maximum amplitude? That will be plus 10, and minus 10 millivolt will be multiplied with 10 to the power 3. So that will be minus 10. So your V0 waveform will be between plus 10 to minus 10. This is not the final answer. Wait for it. Okay. So your V0 waveform will look like sinusoid only, but it will be sinusoid only from plus 10 to minus 10, right? So let me pause the video and make the sinusoid waveform. Okay, so this is how the waveform will look like. What will be the peak value? 10 millivolt multiplied with 10 to the power 3. So it will be 10 volt, and this should be minus 10 volt, right? The output feels like that it should be something like this, but no, it will not be like that, because the maximum value of output is plus 5 and the minimum value of output is minus 5. So wherever you are getting more voltage than plus 5, at that time your output will be saturated to plus 5 only. So let's just assume, why we need to assume here, let's just assume here you are getting 5 millivolt. At this point you are getting 5 millivolt. So here you would have been getting 5 volt, right? Wait a second. Let's just remove this line because that is of no use now. Yeah. So let's say you are getting 5 millivolt here. If you are getting 5 millivolt here, you would be getting 5 volt somewhere here. So this would have been your 5 volt. This would have been your 5 volt. So after that it cannot rise above 5 volt. It will be maximum value it can attain is 5 volt only. So it will saturate to 5 volt here. That's it. This upper portion will not come. This portion will not come. The waveform would look something like this, that it was increasing then saturated to 5 volt. That's it. Okay. It was increasing and then saturated to 5 volt. Well and good, right? And at the bottom, what is the minimum value it can attain? That is minus 5 volt. So let's just assume here you are getting minus 5 volt. So this is the point of minus 5 volt. So here you would have got minus 5 volt. This would have been your minus 5 volt. So it cannot rise above minus 5. It cannot go below minus 5. So it will remain at minus 5 only. Similar things will happen here as well. That this is the maximum it will get, plus 5 volt only. And here as well, minus 5 only. So this is how the waveform would look like. So I couldn't make a better waveform actually. This is how the waveform is looking like, right? Some increases, then it was going towards 10 but saturated at 5, then decreases, it was going towards minus 10 but saturated at minus 5, then again increases, plus 5, again decreases, minus 5. That's it. This is how the waveform would look like, right? So this, let's just call this as time t. And what will be this value? Can you tell me? If this is 2 pi, this is 2 pi, what will be this value? This will be pi. And what will be this? Your input signal is 10 millivolt sine omega t. You are finding 5 millivolt. If you are finding 5 millivolt, what will be the value of omega t you will put? Pi by 3 or pi by 6? Pi by 6, right? Because 10 millivolt sine pi by 6. Pi by 6 is half. So that would be 5 millivolt. So this point is pi by 6. This point is pi by 6, right? And what will be this point? This point. This point. This point will be pi plus pi by 6. Pi plus pi by 6. That would be 7 pi by 6. Well and good. Pi plus pi by 6. Okay, so these points you can also show in the waveform. So this is the waveform for this particular question. So let's see more questions now. So here I will write V naught is equal to 10 to the power 3 V in, but V naught will be between plus 5 to minus 5 only, because there is a certain saturation voltage given, that is between plus 5 to minus 5. Okay, so maximum value it can attain is plus 5 only. I hope it is clear to you. Let's see the next question. OpAmp is ideal. This time OpAmp is ideal. You need to find V naught for the given input. You need to find the V naught value for the given input, and then you need to tell the average value of output. Average value of output. Then you need to tell average value of output. So OpAmp is ideal. So what do you understand by that? If OpAmp is ideal, so if V positive is greater than V negative, that means output will be plus V set. So if V positive is greater than 5 millivolt, then your output will be plus V set. And if your V in is less than 5 millivolt, then your output will be minus V set. That's it. That's it. Nothing else is there. So we have to find the point of 5 millivolt. So what is the point of 5 millivolt? This is our 5 millivolt. Let's just say this is our 5 millivolt. This is 5 millivolt. This point will be pi by 6. What this point will be? This point will be pi minus pi by 6. That means 5 pi by 6. Right, and whatever this point is, no need to worry about that. So for this much of range you will get only plus V set, and for lower range you are getting minus V set. Well and good. What did you understand? That only for this range I will get plus V set, and for lesser range I will get minus V set, right? So let's make the graph. Minus V set here, minus V set here, and minus V set here, and minus V set here. Here in this range your input is lesser than 5 millivolts, so you are getting minus V set. Getting minus V set, and then you will get plus V set for this much range, because between pi by 6 to 5 pi by 6 your input is greater than 5 millivolt. Now again you will get minus V set for this much of range. Then you will get this much range, you will get plus V set, and then again you will get minus V set. So this cycle will go on. Well and good. So this cycle will go on. So this point is pi by 6. This point is 5 pi by 6. This point will be some 2 pi plus pi by 6. 2 pi plus pi by 6. This will be 13 pi by 6. 13 pi by 6. 2 pi plus pi by 6. Okay. And this point will be 2 pi plus pi by 2 would be 5 pi by 2 minus pi by 6. 14 pi by 6 or 7 pi by 3. This point will be 7 pi by 3, I guess, because this is your 2 pi, this is your 2 pi. and this is your pi. So 3 pi, sorry, 3 pi minus pi by 6. So this point will be 3 pi minus pi by 6, because this point will be 3 pi. 3 pi minus pi by 6, that would be 17 pi by 6. This point is going to be 17 pi by 6, right? And the waveform will go on. So if I make so this waveform will go on till this point. And this point will be 4 pi plus pi by 6, 25 pi by 25 pi by 6, right? And then it will again rise and will continue. So what do you think, what is being repeated? Which waveform is being repeated? This much of waveform is being repeated again and again. Are you getting this point? What is this gap? This gap is 5 pi by 6 minus 8 pi by 6. This gap is 8 pi by 6. What about this gap? This gap is 4 pi by 6. What about this gap? This gap is again 8 pi by 6. Next gap will be 4 pi by 6 only, right? Next gap will be 4 pi by 6 only. So this 8 pi by 6 gap and then 4 pi by 6. For 8 pi by 6 gap, the output is plus 5. And for next one, output is minus 5. Plus 5. Minus 5 and plus 5. Sorry. Minus 5 and plus 5. So here it is minus 5 volt. Then plus 5 volt. Minus 5 volt. And then plus 5 volt. You need to find the average value. What is the average value? What do you mean by average value? Area divided by time period. So area of a period divided by time period. So what do you mean by average? Let me add a page. So average value of output, average of output, area of a time period divided by time period. Area by time period. I told you to remember this thing. Area by time period is the average. So what will be the area? Area will be minus 5 into 8 pi by 6, minus 5 into 8 pi by 6 plus 5 into 4 pi by 6, right? 4 pi by 6, 4 pi by 6. And what is the total time period? That is equals to 2 pi. Total time period is 8 pi by 6 plus 4 pi by 6. That will be equals to 2 pi. Right? Then you need to solve it. I will solve it and write down the final answer. So if you solve it, you get minus 1.67 volt. Right? So this is your average voltage of output. Minus 1.67 volt. You just need to solve it. Okay, so what was the question? This was the given question that you need to find the average voltage of the output. So you just need to draw the waveform. When we draw the waveform, we get to know that for V in less than 5 millivolt, you will get minus V set, and for V in greater than 5 millivolt, you will get plus V set. So this is how your waveform is looking like. But this is not the steady state waveform. This is not the steady state waveform. Here you get the steady state waveform. Minus 5 plus 5, minus 5 plus 5. So minus 5 is there for how much time? This time is pi. Look, you can see this time is pi. And then you have pi by 3 and pi by 3 as well. Pi by 6 and pi by 6 as well. This time is pi, and then you have pi by 6 and pi by 6. Say yes or no. Are you getting this point? So pi plus pi by 3, because pi by 6 and pi by 6 is pi by 3 only. So it is there for 4 pi by 3 time. 8 pi by 6 or 4 pi by 3, you can say. 8 pi by 6 is equals to 4 pi by 3 only. So it is there for 4 pi by 3. And what about this? This is there for this complete time is pi. So pi minus pi by 6 minus pi by 6. So pi minus pi by 3. So this is there for 2 pi by 3 time. So for 4 pi by 3 time there is minus v set, and 2 pi by 3 time there is plus v set. Then you can take the average. 5 into 2 pi by 3 minus 5 into 4 pi by 3 divided by 2 pi, because that is the total time period. That's it. So this is how you can take the average. Well and good? Understood? You can intelligently see that for how much time you will have plus v set and for how much time you will have minus v set. In the waveform only you can see. Right? So that's why I was focusing on these points, because where you will get 5 millivolt, you will get 5 millivolt at 30 degree. 30 degree means pi by 6. So sine 30 degree is 1 by 2, so you will get 5 millivolt at pi by 6, right? And then here pi minus pi by 6, that would be 5 pi by 6. Well and good. Just a simple question is there. The graph of y is equals to x is given. You need to draw the graph of y is equals to x minus 2. So what you will do? You will just shift the waveform by 2. Directly you don't need to draw the graph. This waveform is given. You need to draw the graph of x minus 2. Y is equals to x minus 2. So what you will do? You will shift this waveform by 2 downward. So what will be the graph? The graph will be something like this. This will be shifted downward. That's it. So whatever the point that was at 0, this point would become here at minus 2. So the value of y is minus 2, value of x is 0. Right? You can check as well. At x equals to 0, what do you get? Y equals to minus 2. X equals to 0, you are getting y equals to minus 2. And what will be this value? This value will be 2 into 0. The value is not important. I just need to tell you that if in the x-axis at this side, let's just assume the graph is given as fx equals to some function of x. Then if you need to draw the graph of x minus 2, then you will just shift the graph by 2. That's it. You will shift the graph by 2 downward. And if you need to draw the graph of f of x plus 2, you will shift it upward. We study it in simple mathematics only, but if the guys who are not aware of this thing, that's why I told you. You can recheck as well. This is how the graph of y equals to x minus 2 would look like. So just for the revision, that how the graph shifting works. X minus 2, it is shifted downward. X plus 2, it would have shifted upward. Right? So let's move to this question now. Your given OpAmp is having the gain of 10 to the power 3 this time. The gain is 10 to the power 3. You need to find the output voltage for the given input. The input is same now, but the OpAmp is ideal. So what will be your output voltage? So the simple method is always write down the output voltage. What will be the output voltage? Output voltage will be 10 to the power 3 V in minus 5 volt. V in minus 5 millivolt. Right? So this will be your output. 10 to the power 3 V in minus 5 millivolt. One thing I always need to take care is that your V naught will be always between plus V set to minus V set. So your V naught will always be between minus V set to plus V set. This is what you always have to remember. Right? So these 2 points are there. Now you need to draw the graph of V naught. 10 to the power 3 V in minus 5 millivolt. So what I will do? I will shift this graph by 5 millivolt. I will shift this graph by 5 millivolt downward, and then I will multiply it with 10 to the power 3. Are you getting this point? I will shift this graph downward by 5 millivolt, because V in minus 5 millivolt. This is my V in. What is my V in? V in is 10 millivolt sine omega t. So I will shift my 10 millivolt sine omega t by 5 downward. So what will be the peak value? Peak value will be 5 millivolt and downward value will be minus 15 millivolt. So 5 millivolt to 15 millivolt sinusoid, right? So no waveforms are given. So I have to draw the waveform by my own now. So what I am going to do? I am going to draw the waveform of, first I am going to draw the waveform of V in minus 15 millivolt. Sorry, V in minus 5 millivolt. Because what I need to do, V naught is equals to 10 to the power 3 V in minus 5 millivolt. So first I will draw the waveform of V in minus 5 millivolt, and then I will simply multiply it with 10 to the power 3. So this is my target, to draw the waveform of V in minus 5 millivolt. So I just need to shift it downward. So 10 millivolt minus 5 millivolt will be 5 millivolt only. So this is how the waveform would look like. This is 5 millivolt, but it is shifted downward to huge margin, and that would be minus 15, and then 5 millivolt, then minus 15, like that. It will keep on going, right? So this is your V in minus 5 millivolt. That is, this point will be 5 millivolt, and what will be the downward point? Downward point will be minus 15 millivolt. That would be minus 15 millivolt. This would be minus 15 millivolt, and this is 5 millivolt. Now what is your output? Your output is, what is your output? 10 to the power 3 into V in minus 5 millivolt. Where is V in minus 5 millivolt? This is here only. You just need to multiply it with 10 to the power 3. Then you will get your output waveform. So if I multiply it with 10 to the power 3, what I will get here? 5 volt. So this is what I am drawing. This is my V naught waveform. And if I multiply it with 10 to the power 3, what I will get? Minus 15. Here I am getting minus 15. But you need to make sure one thing. What is that thing? That your output cannot go below minus V sat. What is minus V sat? Your output cannot go below minus 5. And it cannot rise above plus 5. So this is what you need to take care. From minus 5 to plus 5 only. So tell me one thing, is my output rising above 5 volt? No, it is not rising above 5 volt. My output is not rising above 5 volt. My output is till 5 volt only, but it is going below minus 5 volt. It is going below minus 5 volt. So where is my minus 5 volt? Let's just say my minus 5 volt will be somewhere here. This is my minus 5 volt. So if this is my minus 5 volt, after that it will not allow to go it down. So here it is not allowing it to go down more. So this is the threshold. After that it cannot go down more. Okay, and similar thing is happening here. It is going down, but cannot go down more. So here it was going down, but till this point only. Now it will go up and go up only. That's it. So this is the final waveform. Okay, if you confuse yourself, okay, V in greater than 5 millivolt, then I will get plus V set, minus V set. These kind of things you don't need to do. Whenever there is an ideal op-amp, just draw the waveform considering the gain is 10 to the power 3. Considering the gain, whatever the gain is given, considering that gain, draw the output waveform, then see what is the threshold. The threshold is between minus 5 volt to 5 volt. That's it. Minus 5 volt to 5 volt. So any value greater than 5 volt will be reduced to 5 volt only, and any value below minus 5 volt will be reduced to minus 5 volt only. That's it. So this is how the waveform would look like, right? I can make it look a bit better. Let me pause it and make it better. Okay, so this is how the final waveform will look like. So what will be this point? I want to know what will be this point. What will be this point? Can anyone tell? How will you determine it? You need to determine this point. So at this point your output is minus 5 volt. This is your output. Your output is minus 5 volt. Minus 5 is equals to 10 to the power 3. What was your V in? V in was 10 millivolt sin omega t. 10 millivolt sin omega t minus 5 millivolt. Right? So minus 5 is equals to 10 sin omega t minus 5. So 10 sin omega t is equals to 0. 10 sin omega t is equals to 0. So at this point omega t value is pi. So here the point value is pi. Similarly, you can find these points as well. Right? We need to find these points as well. What these points will be? They will be certainly apart pi only. This will be 2 pi. This will be 3 pi. All the points are apart pi only. Why I made it here? अरे यार. This will be 4 pi. Well and good, because omega t will be certainly it will be pi, 2 pi, 3 pi, 4 pi. At 0 the scene is different, but this is how the waveform will continue, right? The steady state waveform will continue something like this, this, and then this, like that, right? So these points are pi, 2 pi, 3 pi, 4 pi. Well and good. Let's move towards the next question. Note the next question. Now we are going to study the next concept, but let's just revise what we have studied till now. So we started with simple introduction to OpAmp. Then we saw there is some input resistance. Then there is again there is an output resistance. Like right. So this is how the internal structure looks like. But the output of the OpAmp cannot go above plus Vset and it cannot go below minus Vset. So this is how the waveform looks like. For an ideal OpAmp, all our gain is infinity, input impedance is infinity, and output impedance is 0. So for Vd greater than 0, if V positive is greater than V negative, your output will be plus Vset, and if your V positive is less than V negative, your output will be minus Vset. So this is how the characteristic look like for an ideal OpAmp, right? Then we saw the OpAmp as a comparator. What do you mean by comparator? It will compare two voltages, whatever the voltage that is given at V positive and whatever the voltage that is given as at V negative. So at V positive we gave V in, and at V negative we gave 0. So if V in is greater than 0, you will get plus Vset. If V in is less than 0, you will get minus Vset in case of ideal OpAmp. But in the next question, the OpAmp was not ideal. Here the OpAmp was having the gain equals to 10 to the power 3. So what will be your output? Output will be 10 to the power 3 V in minus 0. So output will be 10 to the power 3 into V in. So just this waveform multiplied with 10 to the power 3. So what you will get? Plus 10 to minus 10. But one thing I know, that is my output cannot go above 5 volt and it cannot go below minus 5 volt. So output will be saturated between plus 5 to minus 5 only. So it is rising, then plus 5. Going below, then minus 5. Rising, plus 5. Below, minus 5, and then it goes on like this. Well and good. Then I found out these points as well with my basic aptitude, right? Basic knowledge of sinusoid signals. Then I saw this circuit here. Now the negative node is not grounded this time. The negative node is given at some potential. So if V in is greater than 5 millivolt, that means your output will be plus Vset. If V in is less than minus 5 millivolt, that means your output will be at minus Vset. Then I found out those points as well, and also I found out the average voltage of output. So average voltage of output was coming out to be minus 1.67 volt, right? And then I saw the same example, but now my gain is 10 to the power 3 volt per volt. The gain is not infinity. So the similar thing I did. V naught would be equals to 10 to the power 3 V in minus 5 millivolts. So I just drew the waveform. But then I saw one thing, that my output cannot go below minus 5 volt, but it was going below minus 5 volt, so I just clipped it off to minus 5 volt only, then increasing minus 5 volt, and then I found out these points as well. Well and good, very easy explanation, everything is crystal clear. Now we will see the basics of positive and negative feedback that we have already seen. So what is the negative feedback? Some portion of output will be fed back to the input, but it will be subtracted. So V in is directly coming. Now some portion of output is coming fed back to the input, but it is subtracted. So this voltage will be beta V naught. V naught minus V naught into beta would be beta V naught. Now V in minus beta V naught will be fed here. V in minus beta V naught will be fed here, and the output you will receive A into V in minus beta V naught. So what will be your output? Output is for negative feedback. This is what we are writing for negative feedback. So your output is A into V in minus beta V naught, and if you solve it, you get A into 1 plus A beta into V in. So this is your output, right? And one interesting thing that we saw in the negative feedback is that if your V naught increases, then what will happen? This node will increase. If this node increases, since it is getting subtracted, that means this node will decrease. And if this node decreases, that means this node is simply getting multiplied with A. So this node will decrease further. Are you getting this point? And if this node is decreasing, that means if this is decreasing, that means this is decreasing. If this is decreasing, that means this node is also decreasing. If the subtracted node is getting decreased, that means complete value will be getting increased. And if this node is getting increased, that means some node increasing multiplied with A, that means this node will increase. So first you increase your output, it decreased, then again increased, then again it will decrease, then again it will decrease. So this way your output will be stable. Let's just say what I mean to say is that I gave a trigger and I wanted to increase my output, but because of the negative feedback the output decreased. Now it is not keep on decreasing, then again it will increase, then again it will decrease, again it will increase, again decrease, again increase, decrease, and then the output is stable. It's not that it is keep on increasing or keep on decreasing. So output is stable. So for negative feedback, the output is always stable. Also, for checking negative feedback, what you will do, you will short circuit the input. For checking the negative feedback, what you will do, you will short circuit the input and then you will increase the output, and then you will walk around the loop. If your output is getting increased again, that means it is not positive feedback, but if your output is getting decreased, that means it is a negative feedback. Are you getting this point? What you will do, you will short circuit the input, you will increase the output, then you will walk around the loop. If your output is getting decreased, that means it is a negative feedback, and if your output is getting increased, that means it is a positive feedback, that we will see in the positive feedback. So what I am going to write here is that if V naught increases, then in the loop V naught decreases. What does that show? That negative feedback is stable. Negative feedback system is stable. Well and good. All these things we have studied in feedback topology. If you have studied feedback topology from me, certainly you are aware of all those things, right? Now what will happen in the positive feedback? So beta V naught simply coming, the same thing, but now it is being added with the input signal. So V in plus beta V naught, and now this will be multiplied with A. So here you will get A into V in plus beta V naught. So A into V in plus beta V naught will be equals to V naught only. So what you get as V naught by V in, that would be A upon 1 minus A beta. This you can derive on your own. A upon 1 minus A beta, right? You can derive it on your own only, right? So in positive feedback, what happens? If I am increasing my V naught, if this increases, then what will happen? This will increase. If this increases, since this is being added, so this node will increase. Now if this node is increasing, then this node into something, some positive gain. So that means this node is also increasing. Here A and beta both are positive. We are considering that A and beta both are positive. Considering A and beta to be positive. Okay, so this node is increasing, that means this node is increasing, this node is also increasing, then again this node is increasing. Now if this increases, then again it increases, and the output will keep on increasing. So what I did, I gave a trigger and increased the output. Then again it increased, and kept on increasing. So my output is unstable. So there is a positive feedback. So in positive feedback, output is unstable. And what if I had decreased my output? If I had decreased my output, then what would have happened? If I decrease this, what will happen? This node will decrease. If this node decrease, then this node will decrease, and this node will again decrease. So if you decrease your output, I decreased my output, then it kept on decreasing, and kept on decreasing. So my output is unstable. So in positive feedback, my output is unstable. So if V naught increases, then further V naught will increase only. Or if V naught decreases, then further V naught will decrease only. What do you understand by that? That positive feedback system is unstable. Positive feedback system is unstable. Positive feedback system is always unstable. Well and good. Understood? This is a very basic concept of feedback, right? So in the next lecture, we are going to study about concept of virtual short, or should we study it in this lecture only? Okay, in the next lecture, we can see different configuration of OpAmp. So in this lecture only, we will study the concept of virtual short. So now we are going to study the concept of virtual short. So that is a very important concept that is highly used in case of OpAmp. Okay. So what is your V naught? Simply, what is your V naught in case of OpAmp? A into V positive minus V negative, right? If A is equals to infinity, then what will happen? V positive by A is equals to V positive minus V negative. Well and good. So V positive minus V negative would be V naught by infinity. Say yes or no. V positive minus V negative would be V naught by infinity. In case of positive feedback, what will happen to V naught? V naught will keep on increasing, right? In case of positive feedback, your V naught will keep on increasing, and in case of negative feedback, it will be decreasing. It will be stable. It will not be decreasing. It will be stable. So for positive feedback, V naught is unstable. V naught is unstable. Yeah. So for positive feedback, V naught is unstable. So tell me one thing. This value is unstable. This can be completely increasing as well. It can be completely decreasing as well. So can you put it equals to 0? Because you are not sure about V naught. What if V naught is infinity? You cannot put it equals to 0. We are not sure about it, right? Because V naught will keep on increasing or keep on decreasing. What if it goes to 0? Still you cannot put it equals to 0, right? Because you are not sure about V naught. This particular value, that is unstable. So if this particular value is unstable, that means you cannot put it equals to 0. So for positive feedback, V naught is unstable. But for negative feedback, V naught is stable, right? So what is your V positive minus V negative? That is equals to V naught by infinity. So this is a stable value. It will be a finite value, that's for sure. Because this is a stable value, that I know. It will be 1, 2, 3, somewhere between 1 to 3. If you increase V naught from 2 to 3, then it will again come down. Let's just say it comes down to 2.1. Then again it will increase to 2.9. Then again come down. So there will be a certain value. There will be a fixed value. 2 by infinity is 0, 2.1 by infinity is 0, so always it is equals to 0. So in case of negative feedback, V naught is stable, so you can put it equals to 0. So V positive minus V negative is equals to 0. So V positive is equals to V negative. So this is the concept of virtual sort. So what is the concept of virtual sort? Concept of virtual sort. What does it say? Concept of virtual sort says that both in case of negative feedback, inverting terminal. What do you mean by inverting terminal? That we were going to see in the next lecture only. But V negative terminal is known as inverting terminal. V negative. This V negative is known as inverting terminal. So I will write it on the first page only. That this V negative is known as inverting, and this V positive is known as non-inverting. Why it is non-inverting? Because it is positive. Invert means changing the sign. So negative can change the sign, but positive cannot change the sign. So V positive is called inverting, V negative is called non-inverting. Okay, V positive is called non-inverting and V negative is called inverting. So yeah, here. So in case of negative feedback, inverting terminal potential is equal to the potential of non-inverting terminal. That is equals to V positive only. So the potential of inverting terminal is equals to potential of non-inverting terminal. So V positive is equals to V negative in case of negative feedback. So this is applicable only for negative feedback, not for positive feedback. So let's check when the virtual sort is not applicable, when the virtual sort is not valid. So first thing, when there is a positive feedback, I told you when there is a positive feedback. When there is a positive feedback, V naught is unstable. So you cannot comment on anything. You cannot comment on this value. So you cannot say V positive is equals to V negative because V naught is unstable. But in case of negative feedback, it is applicable. The second point is when the gain A is finite. if this gain A was finite, then what would be your V positive minus V negative? It will be V naught by A. That's it. You cannot say it is equals to 0 because the gain A is finite here. The gain A is finite. So if gain A is finite, you cannot apply the concept of virtual short. Why so? Because this value is not equals to 0. If the gain is infinity, then this value will be equals to 0. So if gain A is finite, you cannot apply concept of virtual short. And the third point is when output is saturated. When output is saturated, output can be saturated at plus Vset and minus Vset. But I will put a star mark on this point. Why so? Because there is ambiguity in this particular point. We will deal some circuit when we go deeper into the OpAmp. We will deal some circuit where even if the output is saturated, still the concept of virtual short will be valid. So I will show you some questions where the output is saturated, still the concept of virtual short is valid there. So this is not certain, but at the first point, what we have studied, at the first glance, what we have studied, that if your output is saturated, that means you cannot apply the concept of virtual short if your output is saturated. Okay, why is it so? Simple reasoning is there. Let's just say this is V negative, V positive, and let's just say this is some configuration that we will study in the next lecture. Let's just say my output is saturated. My output is saturated at plus 5, and this resistance is R, this resistance is R, and this resistance is some 2 volt. Now my output is fixed, no one can change it. My output is fixed, no one can change it now, right? So this potential will also be fixed. Say yes or no. If my output is fixed, no one can change this output. This is my input, no one can change this input as well. So if your output is fixed, that means this node has to be fixed as well, no? Why so? Because let's just call the potential of this node equals to V, and in the OpAmp there is always 0 ampere current. In OpAmp there is 0 ampere current. I told you for an ideal OpAmp there is 0 ampere current. Okay, I forgot to tell you this thing. For an ideal OpAmp, here I showed you, no? So what will be the input current of an OpAmp? It would be 0. For an ideal OpAmp, input current is 0. Remember it. I in is 0. This is your I in. I in is 0. This can also be your I in. Always this current is 0. This current is 0 ampere for an ideal OpAmp. Okay. So where we were? So what I was telling? Yeah. So if this current is 0, then what will be the potential of V, this node V? That would be V minus 2 by R plus V minus 5 by R is equals to 0. So 2V is equals to 7. So V will be 3.5 volt. So if your output is fixed, that means this node will also be fixed at 3.5 volt. So how you can say both potential are equal? No, they are not equal, right? Because output is fixed. So that's why when output is saturated, still your virtual concept, when output is saturated, you cannot apply the concept of virtual short, right? Why is it called virtual? Why there is a word called virtual? Why we are not calling virtual short? Why we are not calling it short directly? Why is it virtual? What is the meaning of that virtual? That we will see in the next lecture when we study about the non-inverting amplifier. So when we study about non-inverting amplifier, I will tell you why do we call it virtual. This you understood. When output is saturated, you cannot apply the concept of virtual short, but still there will be some cases where there will be some change in the circuit because of the saturation in the output. There will be some inductor involved, there will be some capacitor involved. So because of that, the V negative node will change. If V negative node is changing, then something will happen in the circuit. But that we will see later on when we dive deeper into the OpAmp part. But for now, you need to consider that if your output is saturated, your concept of virtual short is not valid. Well and good. Everything is crystal clear. So whatever that we have studied, that is clear. So first we studied about comparator and all those things. Then we studied about feedback. In negative feedback system is stable. If output increases, then it will eventually decrease. Then if it is decreasing, it will eventually increase. Increase, decrease, increase, decrease. So output is stable. But in case of positive feedback, if you are increasing the output, it will keep on increasing. If you are decreasing the output, it will keep on decreasing. So the output is not stable. When we study the concept of virtual short, then what will happen? Both nodes are equal. V positive node is equals to V negative node, but only when your output is stable. If your output is stable, that means only when in negative feedback. So in negative feedback, your output is stable. So for negative feedback, your concept of virtual short is valid. But for positive feedback, your concept of virtual short is not valid. There is one more explanation of concept of virtual short that is very, very intuitive. We will certainly study about it. I have already posted it on YouTube. We will certainly study about it. But when when we will study, when we dive deeper into the OpAmp. So in OpAmp, you cannot cover all the things at one point only. Slowly you will dive deeper into the OpAmp, you will understand a lot of new things, a lot more pages will open. So we will see one more explanation of concept of virtual sort, but after we study Smith trigger. So after that we will study it. Okay, no worries about that. After studying Smith trigger, we will certainly study about the concept of virtual sort once again. Okay, so these kind of explanation will uh, enhance your knowledge, and it will help you to clear the interviews also. Not just the theoretical knowledge you will have the practical knowledge as well, that why the concept of virtual sort is being valid, but that we will see after clearing the Smith trigger part. Okay, so everything is crystal clear. In the next lecture, we will study different OpAmp configuration. So first we are going to study about non-inverting amplifier. So for next 3-4 lectures, we are just going to study about negative feedback only the negative feedback, because in the negative feedback, the concept of virtual sort is valid. But in the positive feedback, the concept of virtual sort is not valid. So in the next 3-4 lecture, we are going to study about only the negative feedback. Okay, so let's meet you in the next lecture. Okay, thank you.